Hi, we're going to start chapter 2 and talk about frequency distributions and how they're used in statistics. So let's move forward and we'll look at kind of the basics of a frequency distribution. So when we think frequency distribution, we're actually just thinking of the frequency of times a specific score occurs or a category or range of scores occurs. And then the frequency distribution is a summary that displays those frequencies. It can either be in the form of a table or in a graph. We'll start by looking first at tables, and then we'll move into how they look as far as graphs go. So when we look at just a simple frequency distribution, we need to look at the structure of the distribution, and you need to understand what these things mean. So when you look at the top of this table here, so I'm going to circle this, you'll see the very top is X and F. So X is basically the categories of possible scores, where the column F is the frequencies of those scores. So basically, how many times each of those scores occurred. So for example, the score 5 occurred one time, because as you can see, the score 5, which is represented under the X column, and the frequency is 1. So there was only one person that scored 5. Whereas if you look down here, like at 2, 7 people scored 2. So it's just a way to simplify the data, because otherwise you'd have this large data set, and it would be sometimes, especially if you have like 100 different scores, it's hard to see a pattern, where in this you can see the patterns. So we often will see a simple frequency distribution table, and we'll have to start making some statistical calculations from it. So for example, you see this, it's the summation of X. Remember that symbol, summation, means to add. That's all that means, is add. That's all it means. So add up all the X values. So the thing about this, though, is if I added up these X values, I would be going 5 plus 4 plus 3 plus 2 plus 1. Okay, well, that would end up being, 5, 9, 10, 11, 12, 13, 14, 15. That would be 15. But that would be wrong, because that's only accounting for, let's say if we had one score, X score of 5, one X score of 4, one X score of 3, one X score of 2, one X score of 1. But that's not the case. We actually have 1 5, 2 4s, 3 3s, 7 2s, and 3 1s. So we could either convert that table back to original scores and write down, 5 once, 4 2 times, 3 3 times, and then add them up. Or we could make our life simple, and we could use this sum of F times X. So basically is what you do is you take your table and just multiply X times F. So I would multiply 5 times 1 is 5, 2 times 4 is 8, 3 times 3 is 9, 2 times 7 is 14, 1 times 3 is 3, and then add those columns up, those numbers up. So I would end up, my X times F, I have 5, and I'm going to write it really sloppy because that's the best I can do. 8, you have 9, you have 14, and then you have 3. And then once you add those all up, then you really have your sum of X. So if you'll notice in your order of operations active engagement activity, you'll see there's an X column and F column. Then there's a Y column and an F column. So that's just a way to distinguish, like, okay, here you have scores from this data set. Here you have scores from another data set. So maybe X represents men and Y represents women. So you have frequencies for each ones. So instead of seeing sum of X, you might see sum of Y if you have a second table. So this is just a way that we would use that simple frequency distribution table to start computing some statistics. So each of these tables are basically the same information. It's just we have the group or the frequency distribution, which is this table, versus this table of raw scores. Now this is pretty simple, this raw scores table, because we only have 16 scores in it. If you notice, there's 4 rows. So we have, here's one row, here's the second, 4 columns. Sorry, I'm using the word rows, it should be columns. 4 columns, so here's the first column, second column, third column, fourth column, and each column has 4 scores in them. So if you'll notice, 4 plus 4 plus 4 plus 4 is 16. So we end up with 16 scores. Usually our data sets are much bigger. This is just an example data set. So what we would do is we would transfer this over into our simple frequency distribution. So now is what we have is our highest score possible is 5, our lowest score possible is 1, and is what we do is we count how many times each of these occurs. If you can see, 5 only occurs 1 time, so we put a frequency of 1 here for 5. But then when we look at the score of 4, the number 4, we can see, okay, here's 1 and here's 2, and if we look carefully, there's no more, so we have a frequency of 2 here. Then, the same here, score of 3, we have 1, 2, 3. So you can see where I'm going with this. When we add up our frequency column, so this column right here, it should equal how many scores we have in this total table for number of children. If you remember, we said 16 because we have 16 scores here. So when we add this column up, it should also equal 16. So 3 plus 7 is 10, plus 3 is 13, plus 2 is 15, plus 1 more is 16. So it does equal 16. Now when I say the sum of F, which is the frequency, remember F, oops, that was very scribbly, but there's an F there, should equal either capital N or lowercase n. Now capital N is just the number of scores for a population. A lower n is the number of scores for a sample. It's a different way, it's a notation for distinguishing between sample or population. So it's really important to be using the correct one. So if you notice, I put a lowercase n here because I believe this is a sample of people, number of children. So in that case, I know for a fact that this lowercase n represents a sample size. That's what that really means, sample size. Oops, sloppy, but you get the point. That's the sample size. Whereas if I had a capital N, it would represent population size. It's important for you to start to get to know the notations early on and memorize them, because we won't write out full sentences often. We'll be using notation, and that's how things are reported in the literature. So I would just immediately in this course start writing the notations, and maybe on an index card, and then on the back have what those notations represent, so you can start practicing and memorizing them. It will help you at the end. So next we're going to look at, besides a simple frequency distribution, is a grouped frequency distribution. Now your textbook is kind of confusing because it uses the term simple frequency distribution kind of interchangeably for both, but I always distinguish between a simple frequency distribution as just the original or the possible scores. When I have grouped distributions, I will specify a grouped frequency distribution. So with grouped frequency distributions, we have a set of scores that are distributed into intervals, which basically, so a group of scores. So maybe on an exam, you can score anywhere between 0 and 100. Rather than writing every single, okay, 100, 99, 98, 97, 96, instead of that, maybe I'm going to have, you know, from 90% to 100%. And I'm going to have the data grouped into that category. So that would be grouped data. Where the interval is that range of values. So the 90 to 100, that means any score in between there would be part of that interval. So if I had 5 people that got an A on the first exam, anywhere between 90% and 100%, I would have 90-100 as my interval, and then the frequency next to it as 5 for 5 people. And that's a grouped frequency distribution. So here's kind of how we create a grouped frequency distribution and some of the language for what this means. So as you can see, we have our raw quiz scores over here on this left-hand side. Here's the raw quiz scores. So this is just the original data. So if I wanted to transform that over to a grouped frequency table, is what I would need to do is find out how many intervals I want and then get the width. So when I say intervals and width, is what I'm talking about is intervals meaning the number of rows. How many rows do I want my table to be? And that usually depends upon the type of data you have, how much difference there is between the upper score and the lower score. In this case, 4 intervals works just fine. And then when I talk about width, that's the number of scores included in each interval. So if you look at this, it says 0 to 2. Now most students in their mind, they're like, well, that's a width of 2, not a width of 3. No, we're not subtracting the lower from the upper. We're counting how many numbers are included. And we have to include the bottom number as well as the top number. If you use your fingers, and I suggest doing it every time because it'll help, 0, 1, 2. I have 3 fingers up, so that's my width is 3. So then I would just put these numbers into that grouped frequency distribution table. Now if you'll notice, it says 9 to 11 and there's no scores of 11. The reason for that is because we included the score 0 here. I would suggest you always include a 0 in your frequency distribution table. And this does not always have to end at your highest score observed. You can end it at whatever number it falls on to keep an equal width. So it's really important that this width is the same for all of these. Again, if we add these up, 3 plus 1 plus 5 plus 1, our number of scores is 10. So if you'll notice, there's 10 rows of scores here. There's 10 scores. Now, because this is a capital N, this is suggesting this is a population. This is a population size. So we're not dealing with a sample. That's where a population, you have to know that this means a population. It's a small population, but it is a population. Okay, so when we're creating grouped frequency tables, there's some rules that you have to abide by. So our first rule is what's called equidistant. Equidistant means that every interval has to have the same amount of numbers in it. So that width, if you have 3 at the bottom, you have to have 3 all the way up. You can't change your width suddenly. The only time that I'd say you could change your width is, let's say I am dealing with exam scores, and I have a large gap between 0 and my lowest exam score. Maybe the lowest exam score I found was 30%. Well, I'm not going to expect you to create intervals or rows for all the possible numbers that are before 30%. It's the one time that I'm okay with you putting on that bottom row 0 to and the number below the lowest number, so 0 to 29, and then you can start at 30%. So as long, that's the only time, but that's where you would want to put parentheses to show that that one bottom row is not equidistant. It is different. And no intervals overlap, so you can't have 0 to 2 in the bottom and then 2 to 4, because 2 can't be in 2 different intervals. So you can't have the intervals overlap. And then all values should be rounded to the same accuracy in the data. So keep your math consistent, basically. And so then always to check to see if you have counted or if you've done things correct, the frequency column, when you add that up, it should equal to the original amount of data that you collected or that was used. So there are specific steps to finding your width, basically, and that's really the key, is to find the appropriate width, because otherwise it's just a guessing game. So the first thing you do is you're going to find what is called the real range. So if you'll notice here, we have the real range, and it's h minus l plus 1. Just take your highest number, subtract the lowest number, and add 1. Because what 1 is it's basically accounting for the upper and lower real limits. So if your lowest number is the number 30, actually 30 starts at 29.5 and it ends at the upper 30.5. It's that entire span. So that includes that the upper and lower real limits. So once you get your real range, then you can find that width, which is ultimately our goal. Like, how many scores are you going to include in each interval? So is what you do is you divide that real range by the number of intervals you want. Remember the number of rows. This is kind of a standard protocol. I'm sorry, I've got a tickle. Typically in our class, I want you to use 10 intervals unless I tell you otherwise. So if I don't say provide a grouped frequency distribution using 5 intervals, if I don't say that, just if I say provide me a grouped frequency distribution, you should assume I mean by 10 intervals if I don't tell you a different number. And then once you get that the answer, like from dividing the real range by 10 or otherwise instructed, you take that number and you round it to a whole number. Remember, in this class, rounding should be appropriate. So if you get the number 11.4, you round down, because 0.4 goes to 11. If you get 11.5, you round up to 12. It should be rounded appropriately. Then once you get the that width, then you can start constructing the frequency distribution table. So that's when you start counting from the bottom, and you start counting at the lowest number and include that many numbers in your width. So we'll look at how this looks, because it can be confusing when you hear about it. But these are clear-cut steps that you can use in this class to do this. So here we have a data set. It's a big data set, and this is what I'm talking about. We're looking at large data sets where if I just looked at this, it would be very difficult to see if there's a pattern. And right up here we say, it says 50 healthy American children. So this 50 is how many are in this data set. So what we want to do is look at this data set and find the real range. That means we need to locate the highest number. This is the tricky part. Sometimes you have to be really careful. So in this column, I have 110 is the highest. I kind of look at it, break it down. 110 is the highest. When I look, and that's in this column, okay? I'm going the first column. So 110 is in the highest in that column. Then when I look at the second column, okay, I can look at these numbers. Oh, 140 is the highest in that column. So we know that's higher than 110. So we found the higher of those two. Then when I look in this column, my highest number in this is 110. Well, that's not higher than 140, so I'm still looking at 140 as being my highest so far. Then I look in this column. I know this sounds difficult, like why are you going through all these steps? But the hardest part sometimes is when you have a large data set is spotting the highest and the lowest number. So in this 109, okay, that's not higher than 140. So now I'm going to go to the last column and look and see, go down, oh, we have 175. Oh, 175 is higher than 140. So bam, okay, I have my highest number, okay? Then I just go through and do the same thing with the lowest number. The lowest number is 0, because 0 is the lowest basically. So there's my highest and my lowest. And then we add that 1. So our real range is 176. So now we have step 1. So we found the real range, okay, 176. We can move on to step 2, which is finding that the width, right? So we're going to take the 176 that we just obtained and we're going to divide it by the number of intervals, which is 10. Remember, in this class, I always give you data that fits 10 intervals unless I tell you otherwise. So that width ends up being 17.6, but we don't want to use decimals. We want to use whole numbers. So we're going to round 17.6 to 18 because 0.6 rounds up. So now we know each interval is going to hold 18 numbers, and we can start constructing that frequency distribution. So in social behavioral sciences, we always have our frequency distribution table starting at the lowest numbers and going up. If you do it the opposite, it's completely wrong for social behavioral sciences. It needs to be in APA format. So as you could see, 0 to 17. So you're going, why 17? It should be 18, right? No, because if we said 0 to 18, that's actually a width of 19, because you have to include the 0. So one thing that I often do is I take basically the last, so like let's say I have, this is my upper boundary for this interval, is what I do is I take this 17 in my calculator. I'm going to circle this so you can see. This is the higher of this underneath interval. I know this next one is going to be 18, the lower boundary, but if I want to find what my upper is, I just take this 17 and I add my width to it. So 17 plus 18 equals 35. Then I take 35 plus 18 and that's going to equal 53. So then you're accounting for the upper and lower boundaries. So if you'll notice all the way up, and remember our highest number is 175, but this goes up to 179. That's okay, because what we want is 175 to be somewhere in this upper interval. It doesn't have to be the very top, it just needs to be somewhere in there. So that way we're maintaining equidistance. Remember, equidistance is that every row includes the same amount of numbers, 18 values. And then we have no rows overlapping. So we have, 161 here, 162 here. 143 here, 144 here. We don't have 144 in two different places, or one, you know, we're not sharing. So we need to make sure that the rows do not overlap the numbers. A 0 point is included, so this should be part of your grouped frequency distribution. So let's just say this data started at the number 5, okay? I still want to include a 0. So is what I would maybe do is, or let's just say the data didn't start until 18, the number 18, okay? To make it seem clearer, that it started at 18. And then this number would be 0 is what it would be. And is what I would do is put parentheses around this, because actually this is the only row, if you're doing it to include 0, that it can have a different width. That's only if you're including 0. So that's where I said if I had my lowest exam score start at 30%, I'm not going to start my rows at 30. I'll start my row at 30 in the second row, but over here in this row, I would have 0 to 29. And then I would put parentheses around it. So 0 to 29. And then I put parentheses so that people would know, oh, this is a different width because we're including that 0 point. So it's really key to make sure you're implementing the 0 in there. So there is some real advantages to grouped frequency distribution tables. First of all, if you have large data sets or large range within the data set, it's easy to combine the numbers, whereas instead of you would have to list every possible number. So if you're looking at exam scores 0 to 100, you have literally, 100 rows with every possible score, even if people didn't score those. You can't skip. So the advantage to a group frequency distribution table is simplifying that data. The disadvantage is that you do lose information. You can't see individual scores. If I have like an exam, a grouped frequency distribution for exam scores, and maybe I have my exam scores going from 70 to 79%, okay? Maybe every single one of the people within that 70-79% scored 79%, but I can't see that. It could be anywhere in there. So what it does is it loses some specific information, and the wider that interval, the more information is lost. So that could be a disadvantage of that. So when you do a grouped frequency distribution table, or when you see one, you'll see that it's not just the frequency columns that are included. Now, and this is just, it's cut off here just so that you can see what this looks like. Instead of just including these two columns, we need to include two other columns. So the relative frequency and the relative percent. So relative frequency, in my mind, is easier to just think of it as P, or proportion. So right now they're talking about relative frequency, but later on in the semester it's automatically known as P, lowercase p, which equals proportion. And to get proportion, or relative frequency, you basically take the frequency of that score and divide it by how many scores total there were in the entire study. So for this first relative frequency, we had 2 divided by 45, because if you'll notice down here, I kind of highlighted over it, this is n equals 45. So to get it, we had 2 divided by 45, and then we ended up with 0.04. So its relative frequency is always reported as a decimal. You never report it as a fraction. It's always as a decimal. So that helps to kind of summarize large data set and say, okay, here's the proportion. And then once we get the relative frequencies, which is proportion, we can actually add those up, and you should be getting 1, which we're going to talk about what we use these grouped frequencies for as far as graphing or any frequency distribution. So often we'll use histograms, or we will use histograms for any continuous data. So remember, we talked about measurement scales. Histograms are going to describe continuous data. So basically we're looking at, here's the scores on the x-axis, and here's how frequent they occur on the y-axis. So if you'll look from 0 to 2, we had a frequency of 96. So here we have the top of that is 96. The bars are touching because the data is continuous, meaning that there's any number in between, any of those decimal points in between. And we also have both the y-axis and the x-axis starting at 0. That is important. Otherwise, we're biasing that data and making it seem skewed when it shouldn't be. Remember, we talked about that in the beginning in chapter 1. Another thing, type of graph that can be used for continuous data is a polygon, a frequency polygon. Again, we have our x-axis at the bottom, our y-axis shows our frequencies. This is the same data, but it is what we have is it's shown by lines. So for each interval, there's basically a point, a dot, as you can see, this dot, a dot here, for each point. These are connected by lines. So it's connected by a line, and the lines should always be closed. So this should always drop down to 0, and this should always close at the next interval at a 0 frequency. So we want to make sure that those lines are closed off at the end. And that's a polygon. I often use these when you have two variables that you want to measure frequencies on, like maybe the difference between females and men on something, so that you could see the two differences. That's what I typically use it for. And then we can have bar charts, which are used for discrete or categorical data. So bar charts will show us the frequencies of specific categories or numbers. But if you'll notice, there's space in between these bars, space between them. That's telling us you can't have any decimal in between. So if you notice, this is number of naps. If I took one nap today, that's 1. If I take 1.5 naps, it's 2 naps. If I had any portion of a nap, even if my nap was cut short, it's still considered 2 naps. I can't have 1.5 naps. So these are whole numbers, and these are discrete or categorical data. So a bar graph, when there's spaces in between, is showing that there are no decimals, that it's only whole numbers or only categories. They do not touch on that axis. So specifically used for discrete data. Another one that is used for discrete data is a pie chart. Typically, I don't use these very much. They're usually used when we're talking about like proportion of demographics for certain things, like proportion of like it's showing here degrees, high school, graduate, doctoral degree, master's degree, and they summarize into the relative percents. And so the problem with a pie chart is the fact that it's not always clear. These colors sometimes can look very similar. So for me, this category of high school graduate looks the same color as the master's degree. So we have to be really careful when we are creating these pie charts that we're really clearly seeing the differences, and so that the categories are not so similar that it's hard to tell the difference between. So sometimes we'll use patterns, like one is like polka dot, one is checkered, sometimes that's a useful way of doing it, because colors some people are colorblind, and some people have difficulty distinguishing between similar colors. And it can also depend upon the types of technology you're using that can make it a problem. So you'll have an opportunity to create a pie chart in the near future, but it'll be more just for fun and to see if you can manipulate the data to get it into a pie chart. It's more for a lab component to get that computer practice. So that was the entirety of chapter 2. Please don't hesitate to use those videos. They're very helpful. The videos on chapter 2 would be the frequency distribution, the percentile points. They're all in the resources for PowerPoint presentations and slides in your module 1. So if you have questions, please don't hesitate to email me or see me during my office hours.